Okay, so I'm going to show today, at least, I'm going to show how to find area of regular polygons. And this works for any regular polygons, doesn't matter how many sides or whatever to it. What I always do though is list out this criteria. Because I find if you list this stuff out, it'll help you keep you organized in all the numbers you're going to get, because you're going to get a lot of different numbers. So the first one's capital A, which is area of the polygon, which is 1/2 times a, little a, times p. Now p is perimeter, which is n times s, which n is number of sides, s is side length, and that little a that was in the area of the polygon, that's their apothem. Let me go over what that is too. And then another term that you may not see so often, depends on who you have, but I like to use it. It's called theta, and I use it for the central angle of the polygon. And that's equal to 360 divided by n. So here's our first example of a triangle. Now the idea behind why I use all this stuff is, imagine it's inscribed in a circle. Alright? What we have is the center of our circle is also the center of the polygon. Imagine I draw a dotted line down all the way to the base of my polygon. This little dotted line, that's the apothem. Okay, any line to a vertex, to a point. Okay, any line to the vertex or point of a polygon, those are the radius. That's the radius. And the little dotted line is our apothem. As you see, we can have dotted line on each side. It doesn't matter which side. In the process of doing that, we form a little triangle here. This is the triangle that we're going to use to find out all this stuff. Alright? So I'm going to draw that triangle. You can see how it has a side length of 8 still. I'm going to draw that triangle over here, so that's what we're dealing with. So it's a triangle within a triangle for this example. So our side length is 8. So I'm going to come back over here to my list of criteria. Let's go to the list what our side length is. 8. Number of sides, we have 3, because it's a triangle. This image, go off our base in our first image, 3. So therefore we can find perimeter, which is 3 times 8, 24. Alright, we don't know the apothem yet, but we can find the central angle because it's 360 divided by n. Or no, sorry, I got this backwards, my bad. Side length is 8. Number of sides is 3. My fault on that. So 360 divided by 3 equals 120. Alright, so we have all that information now. So make sure you guys fix that if you're following along. We have all that information. Let's come back to that side, this little triangle that we drew up over here. This is the central angle right here. Because if you go back, that's my 360 divided to 3 equal parts. So this is 120. Alright? So let's draw what we do. Cut that triangle in half. Because remember, this dotted line, that's our little a. Now if we cut this in half, that means we cut our side length in half. That means our base now is 4. And that means this angle is 60. Okay, so we cut everything in half of this triangle, which this triangle is this triangle again. So now we need to find our height, our apothem. Now since we cut it in half, this forms a right angle. Let's use trig. So we go, I mean, you can use, it's a special right triangle, you can use that. I say get in the habit of using trig because it's going to happen all the time. And most of your polygons won't have special right triangles. So we have a tangent of 60, and I'm going to use tangent because it's opposite and adjacent. Equals 4 over little a. Of course, you multiply by a. You get that, and then divide by tangent of 60. So a Let's just go to the Polygon calculator. 4 divided by tangent 60. Make sure you're in the right mode. You should be in degree mode if you're using your graphing calculator. 2.31. Around 2 decimal places. We won't get an accurate answer, but it's better than nothing. So we get that. That's our apothem. Sorry, I didn't use blue. That's our apothem. Now I have my apothem, I have my perimeter, so let's plug it all into this formula. 1/2 2.31 times 24. Get our calculator back again. So basically 12 times 2.31 gives us an answer 27.71, and it's in units squared, whatever units it is, squared. So that's how you find an area of a triangle given they give you a side length. So I'm going to do 2 more examples. So I'm going to go ahead and erase all this. Again, if you want to develop your own process for doing it, that's fine. I like this process because it keeps it all clean and it keeps the numbers straight. You're going to see within the next 2 examples that I do. So we're going to deal with the Pentagon this time. My drawing will be terrible. Alright, so this is what we have, a Pentagon. And we're given that this is 10. Now remember, since it's going to the vertex, it's going to one of the corners, that's my radius, that's not my apothem. But, being how we have all this stuff, we can still fill out some of our little table. So that means we come back over number of sides, we have 5. We don't have side length, we don't have the apothem, but we do have our central angle, 360 divided by 5, so 72. Alright, so that's what we have. What I do, imagine we have another little line going to another vertex. We have a little triangle here. I'm going to draw that triangle over here. And I know this is 10, this is 10. Because again, this is the radius. Imagine it's inscribed in a circle. Again, this angle, that's our central angle, 72. That's why we find that. Cut this in half. Forms a right angle. The dotted line is our apothem. Alright? So we have our apothem. We want to find S. That's our side length. This whole thing is S. Now remember, this dotted line cuts it in half. So that means this, I'm going to call this X, because that's half of S. So I need to find X and A. I cut 72 in half, so this makes it 36. I have the hypotenuse, so I'm going to use cosine and sine to find A and to find X. So let's find A first. We're going to say cosine of 36 equals A over 10. Multiply by 10. We get 10 times cosine of 36. We're going to get 8.1. because it's 8.09 to 8.1. Let's find x. That's going to be sine of 36 equals x over 10. So 10 times sine of 36 equals 5.87. Now remember, that's x. It's only half of s. So go ahead and multiply that by 2. We multiply this by 2, and we get s equals 11.75. Go ahead and make sure the camera can see that. So s equals 11.75. All right? So I have my a. Let's go ahead and put it back in over here. Sorry, I used different color. 8.1. My s is 11.75. Now, let's figure out all our calculations. So, we go ahead and multiply 11.7 times by 5, so we get our perimeter, which can end up being 58.7. Now let's plug that all into our area for polygon. So 1/2 58.7 times 8.1. And we're going to get 238. .05 is our answer. That's our area of a polygon. Okay. Again, it's unit squared, so whatever unit you're dealing with. All right. So there's an example of where it gives you the radius, and you need to find the apothem and the side length. So you got to make sure you double it up. So one more example, and this one's going to be of a hexagon. Again, it's supposed to be a regular hexagon, but my drawing skills are terrible. So they give us the apothem this time. Because the apothem, again, remember, comes from the center of our shape to the side of our polygon, not to the vertex, not to a corner. So that's what it gives us. So let's fill out what we have. And this is the nice part about this chart. You'll always have something. We'll always have the number of sides. Looks like 6. We have the apothem, which is also 6. And let's figure out our central angle, which is just 360 divided by 6. Which equals 60. All right, so we need to find our side length. Again, draw that triangle. Because imagine that's our triangle. So, what I have, I'm recording by the way. So what I have is my apothem is there. This is what I need to find is my whole side length. Got me nervous now. And that's x. Again, remember this is my central angle, which is 60. And that cuts this in half. So to find x, we use our trig again. Tan of 30 equals opposite over adjacent, so x over 6. Multiply by 6. And we get 34 or 3.46. Remember though, you need to multiply that by 2 because that's only half our side. So our S equals 6.9. We're good with that. We'll go 6.93. So we come back over to our little chart, put in 6.93 there. And again, just plug in everything that we have. So find our parameter first. Go multiply that answer by 6. You get 41.56. And then go ahead and multiply that by 6 again because we're going to plug it into this formula. And after we plug all that in, we get 124.7. So that's to find the area of another polygon. Those are 3 examples. For the most part, it's all the same work. This is 11.4 from our geometry book that we use. But, there's also composite shapes in there. That's pretty simply just break up the shape into different shapes that you know of and go from there. So hopefully that will help you guys with area of regular polygons.